So we're going to talk about finding the units given a density and creating a definite integral. So we're given that the density of books on a 6-foot shelf is given by b of x equals 0.5 plus 1 over x plus 1 squared, and that's measured in pounds per inch, where x is the number of inches from the left end. So ideally, if we knew x, we plug it in, and that would give us how many pounds per inch at that particular location measured from the left end. So first thing we need to think about, if we were to multiply b of x times delta x for our slice, so if it's a slice, we always put a sub I in there, the ith slice, the units would be pounds per inch, and delta x is our change in x, while x is measured in inches, so times inches, and that'll give us pounds. So we would expect our Riemann sum and our definite integral also to be measured in pounds. So if we were to calculate the integral from 0 to 72 of 0.5 plus 1 over x plus 1 squared dx, we would have 0.5x, antiderivative here, it's going to switch signs because it's going to be plus negative 1 over x plus 1. Take the derivative if you want to see how that works out. From 0 to 72. Let's go ahead and plug in our limits. We have 0.5 times 72 plus negative 1 over 72 plus 1 minus 0.5 times 0, which will just be 0, plus negative 1 over 0 plus 1. That will not be 0, as you can see. So I have half of 72, which is 36, minus 1 over 73, minus a negative 1, so plus 1. So we basically have 37 minus 1/73, which is really close to about a 0.001. So this is going to be roughly about 36.99, let's say. And the units on that are pounds. Now let's think about what we did. We did 72 inches. We did from 0 inches to 72 inches. 72 inches is the same thing as 6 feet. So this was giving us the density on a 6-foot bookshelf. So what we found is the total weight of all the books on this 6-foot bookshelf is about 36.99, or we could probably round that up to 37 pounds. So what we did is we integrated over a varying density in order to get total weight.